Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, this is the lecture 2 of the revision class for the 8086 pin diagram, and also we talk about here the peripheral interfacing of the 8086 microprocessor. Now, what we have done so far, we have seen the pin 1, which is ground, and pin 20, which is ground, and then pin 40, which is for the voltage, and then from 2 to 16 and also 39 to 35. Okay, these pins are either used for data or addressing. Okay, so when they are used for data and when they are used for addressing, so how we figure it out. And next, so these 2 to 16 and 39, that means 16 pins, they're multiplexed with data and address, and rest these 4 pins, they're multiplexed with the status and address. So address and status. So these pins are never used for data, because for data we have only 16 bits, but for address we have 20 bits. That means from 2 to 16, then 39 pin, that is 8015. Okay, and also because this 2 to 16, it starts from 80 up to 8014, then this 8015 is on the pin 39 on this side. Okay, then these pins, that means 16 pins, will be used for for data. Okay, because for data we need only 16, but total we have 20 pins, so out of them 16 will be used for data, and rest 4 pins, they are used when we use the address, because for address we need all the 20 pins. Okay, that is from 2 to 16, then 39 to 35, that is 20 pins. So when it is used as a data, multiplexed as a data, then from 2 to 16 and 39 pin is used for data, that is 16 bit. Okay, then these 4 bits which are left out will not be used for data, rather they will be used for status, S3, S4, S5, S6. When it is addressing, it will be all the bits, all the 20 bits, including this A16, A17, A18 and A19 are used for addressing, because we need for addressing 20 bits. But when it is data, we use 16 out of them for the data, and rest these 4 are used for the status, and it depends on the ALE. Okay, so ALE will actually tell us whether we have to use it for data or for the addressing. So it depends on if ALE is logical 0 or logical 1. So what is ALE? It's called as the address latch enable. So when the address latch enable is 1, that means we have to take address. So in that scenario, all the 20 bits will be used for addressing. Okay, but when ALE address latch enable is 0, that means it is disabled, so we are not going to use it for the address, rather we are going to use it for the data, but we can use only 16 bits for the data, and rest 4 are used for the status. So they will be used 16 bit for, out of 20 bits 16 bits will be used for the data, and these 4 will be used for status, and it will be when ALE address latch enable is disabled, it is 0. When it is enabled, then all the 20 bits will be used for the addressing. When it is 0 disabled, only 16 bits will be used for address, for data, because for data is here 8086 is 16 bit only, and the 4 left out bits will be used for the status. So in the status we got the S3, S4, S5, S6, even S7 we are talking about, and even here are S0, S1, S2. Okay, we will talk about these things later, because there are 2 multiplexing here, and it depends upon the minimum mode or maximum mode of the 8086, because our 8086 works in 2 modes, this is minimum and maximum, and we will talk about them later. So right now we will talk about these bits, S3, S4, S5, S6, wherein we have firstly S3 and S4. So what are they used for? So S3 and S4 are used to identify the segment, because we know our RAM is divided into 4 segments, right? That is our extra segment, we have the code segment, we have the data segment, we have the stack segment, and so on and so forth. So which segment register we want to work with, it depends upon what combination of S3, S4 we have. So what combinations S3 and S4 we have? Say for this is S3 and this is S4. So we can have either combination 0 0, we can have 0 1, we can have 1 0, and we can have 1 1, right? So what information they give us when the S3 is 0 and S4 is 0, when both are 0? Okay, so rather I should say here S4 and this one is S3. When S4 is 0, S3 is 0. So we are talking about the extra segment. Okay, so we are, when S4 S3 is 0 0, if we have selected this as 0 and this as 0, that means we are trying to access the extra segment. So which segment we are trying to access, that is it. So if it is 0 1, we are talking about the stack segment, and if it is 1 0, we are talking about code segment, and if it is 1 1, we are actually talking about data segment. So which segment you want to access depends upon what is the value in S3 S4 combination. Now here the S5 reflects the state of the interrupt enable flag, which is here. Okay, here interrupt enable flag. What is the state of interrupt enable flag? It will reflect on that basically, because this interrupt enable flag will allow our system to take interrupts, because if we can have either the single processor or that's what minimum and maximum mode will tell us, because Intel 886 can work in the minimum mode and maximum mode. In minimum mode it works as a single processor, and in a maximum mode it works on a multiple processors. Okay, so that means if this processor is working on something, if interrupt enable flag is set, that means we can take interrupt from the other processors. Okay, so this flag will reflect that. So are we going to take the interrupts from other processors or not? So S5 reflects the state of the interrupt enable flag. So you have to understand this is used in the maximum mode, because maximum mode we work in a multiprocessor system where we can do multitasking and multiple processors work together, okay, in 8086, right? But if it is a minimum mode, we have only a single processor working. Okay, in that case we may also have interrupts. For example, here we have interrupts and non-maskable interrupts. We'll talk about them shortly, but those interrupts are from the input output devices, the peripheral devices, or some devices want to have the attention of CPU, they have the interrupts. Okay, and but in the ALE sorry, if the interrupt enable flag is set, that actually means that we are trying to have an interrupt from the other processors. So S5 reflects that. Now here there are two more which are left out, that is S6 and S7. Basically S6 is always 0 and S7 is undefined. Okay, so when it is 0, it's not used at all, and it is not defined at all for anything, right, in 8086. So actually they are used, they are for the future purposes. Now we have one more here, that is the read. Okay, pin number 32, which is the read. So what it does, it's a reads signal used for read operation. If you want to read, okay, it is an output signal, and it is works on active low. That means when this one is 0, because it's an complement of that or inverse of that, that means it will become high when we have the signal 0. Okay, that's why we say it's an active 0. So it's simply used for reading. Now the next bit, which is pin number 22, which is ready. Ready means, actually why we want to be ready here is because your processor is having a high speed and your input output devices are very slower. So we have to tell processor whether the device is ready or not. Okay, so that is why we have to set this 0 or 1. If it is 0, that means it's an basically active high signal. It's not bar like we had the read. So that means if it is 1, that means the devices are ready. We can go for the reading from the devices, or passing data to the devices from the processor. Okay, but if it is 0, that means the device we are trying to talk with is not ready, so we have to wait. The processor has to wait then. And we have the reset pin number 21, which simply is an active high signal. When high, it microprocessor enters into the reset state and terminates the current activity, but it must be active for at least 4 clock cycle to reset the microprocessor, because our um, clock has the 4 cycles, that is T1, T2, T3 and T4. After 4 cycles, the next clock cycle starts. So we have a 1 cycle having 4 clock cycles, then next 4 clock cycles, then next 4 clock cycles, and next 4 clock cycles, and so on. We also have the clock here, as you could see, as a line, as a pin number 19, which is a clock. So to understand this better, let's go for the diagram which talks about these. So to understand it better, let's see this diagram where we have a lot of things. So this is my 8086 CPU, wherein we see all the pins here, like A D0 to AD7, then A8 to A19, and all the 20 pins here. Okay, then we got these status pins, and then we got the clock, ready and reset pins, and minimum mode and maximum mode. So this is my overall CPU. Okay, but what about the other guys here? We have, if you could see, the 8284. These are the different ICs attached with the microprocessor which does the job. The first thing is the clock generator, 8284. So 8284, remember, 8284 is the clock generator. Then you see 8282 or 8283. This is a latch. Latch is like a flip-flop. We talk about it a little bit more. Then we can see the 8288 is a bus controller. Okay, and we have the 8286 or 8287, and this is what's called the transceiver. So we have got 4 things attached to the microprocessor, the 4 ICs. One is 8284, which is the clock generator, 8288, that's a bus controller, 8282 or 83, that's a latch, and 8286, that's a transceiver. Now let's first talk about this latch. So why we use a latch? Because we know the address and data. We have total 20 lines and we have multiplexed them. We multiplexed? We either use them for the data and either use them for the address, or when it is used for data, it's also used for the status. Okay, we have seen that, and we use data or status. The first 16 bits are used for the data, and rest 4 are used for the status. When we know when this ALE is actually 0, but when this is 1, it is all the 20 bits are used for address. This is called multiplexing. But who will demultiplex it? Who will be in charge of the demultiplexing? Okay, and that is the 8282 or 8283, which is the latch. Okay, so what it does is it demultiplexes the addresses and the data. Okay, address and data bus, and it is just an 8-bit. We should understand that this latch is 8-bit only, but we know we have a 20-bit address. So if we have one latch, that is 8-bit, then we have another latch, the total becomes 16. We still need 4, so we need another latch. So we need to have 3 latches. Remember that we have here, it's the half diagram, we have here 3 latches. Okay, and they are connected with the ALE, and ALE is connected with the strobe of the STB or strobe of the 8282 latch. Remember that the ALE is connected with the strobe of the latch, and this helps, in short, this helps in the demultiplexing of data and address bus. How it actually works is when the ALE is 1, okay, what it does is it holds the it becomes transparent. It doesn't work because then at that time it takes all the 16 bits for the address. But when ALE becomes 0, what it does is it gets activated, and it does what? It stores that address in it. So because it's a latch means some kind of a memory, like flip flop. We have latches and flip flops, okay? So which are kind of a memory. So it's a kind of a buffer. It holds that address because we need to know which address we have, okay? And it then converts, demultiplexes our address, those bits, into the data bits, so that we can transfer to and fro the data, and also the status bits are activated. So when ALE is 1, it's actually it becomes transparent. The address which is coming from here goes out. So but when ALE is 0, it stores that address in it, okay, and converts the address bits into the data bits, so that we can transfer the data now to and fro. So what we are saying is that if ALE is 1, okay, if the ALE is 1, which is connected with the strobe of the 8282 latch, it becomes as if it is not there. So the address which is here passes out and selects whatever the address we want to select. But if it is 0, so that means we activate this latch, and this latch actually stores the address in it. Whatever the address comes up, it gets stored here, okay? It's working now. And this then data enable pin, that's pin number 26 on our microprocessor. It is actually oblique on the, it's missing here, so it is a inverse. So this pin decides the transceiver, okay? We got here the transceiver. This gets activated using the data enable. So if it is low, if it is 0, because 0 inverse is 1, so that means, because this is the complement of it, so 0 inverse. So if it is 0, the data enable pin is 0, that means it gets enabled, the transceiver gets enabled, okay? Because we are saying that these address bits, and because the bus we are using is for the both address as well as data. Now this whole thing will be used for the address, so for the data now, and that too only 16 bits, okay? The 4 bits we don't need, okay, for 4 bits which are used for the status. Now this will be used for data, okay? Now these are the top ones which are used for only the address, but these guys are used for the 16-bit data. Now this data will be passed to the memory or input output devices, whatever the devices we have, input devices, or from the input output devices to the processor, because this is bidirectional. It will pass from processor to memory or input output devices, or from input output devices and memory to the processor via the transceiver. So transceiver is in between, so it acts as a buffer between the two, okay? And this will be enabled only when here this latch, for the latch the strobe comes from the ALE which is 0. That means we have to now use these address lines, not for the address lines but for the data, okay? But when it is 1, so all the address lines will go straight and they will not be stopped, and they will be as if this strobe doesn't, as if this latch doesn't exist. But when it is 0, okay, ALE is 0, so it will store the address, okay, and DEN will be 0 at that time. That means this will activate our transceiver. So transceiver will get activated, and it has to transfer data to and fro, okay? Now let's talk about this transceiver. So transceiver gets activated when? So transceiver gets activated when ALE is 0 here, and this latch stores the address, and now these address lines are free because the address which was on these lines is stored here. So we don't require these lines now for the address. Rather than we can use out of these 20-bit address lines, 16-bit we can use for the data, and that data has to pass to or fro using the transceiver. So hope you are understanding it properly now. So transceiver 8286 or 8287, it has actually, so we have to also see two things here. So how many transceivers are will be, because I told you for this latch we need three latches because this is 8-bit, and how many transceivers are used here, and how will we decide that whether we have to go for data to or we fro, that means data from the processor to the memory or peripheral devices, or from peripheral memory to the processor, when how we decide that. Okay, this transceiver has 8 receivers. We have here 8 receivers and 8 drivers. So that means I need another this transceiver which will also have 8 receivers and 8 drivers. So 8 receivers will receive data 8-bit, and this 8 receiver will receive 8, so total 16-bit data I can receive, and 8 drivers and 8 drivers, because 2 transceivers I'm having, so 16 data I can send. So I will use receivers to receive data and drivers to send data. Now who will decide that whether we should receive or we should send? So firstly, when will this get activated? This will get activated when den is 0, and that means it is low. When it is low, okay, okay, that's why it's shown, 1 second, why it's not shown here the inverse, because we got the complement here, so this guy is complementing it, so it is showing in a circuit to complement it. So this is when this one is high here, actually it is low here, so low becomes, this inverter will make it high, and which is with the OE, and it will get activated. Now depending upon this T line, okay, which is connected with the DT oblique R, okay, that is data transmit or receive. So are you trying to data transmit or you are trying to receive? This is connected with the T. So T will decide whether we have to transmit or we have to receive. By the way, this data transfer and receive, this is the pin number 27 of our pin number 27, and this was pin number 26. I will show you on the pin diagram. Now as you could see, data transfer and R is complemented. So what does this mean? So this means if we have this pin number 27 of the microprocessor 8086 high, so if it is high, so that means dt is high, what will be out the R, because R is complement, so R at that time will be 0, so it's not going to receive, it's gonna data transmit. So it will transmit data using the transceiver from microprocessor to the memory or input output peripherals. But if it is low, when it is low, dt becomes low, but R is a complement of low, that is high, so this time R will work, it will receive. So transceiver will receive data from memory or a peripheral device and pass it to the microprocessor. That's why it's a bidirectional. Now then we discussed about the latch, we discussed about the transceiver, that is 8286 and 8282 latch, and now we talk about the 8284 IC, which is a clock. Okay, we have the clock which has the rise and fall time, that is rise and fall time of less than 10 nanoseconds, and it represents either logic 0 or logic 1 using voltage. Logic 0 is from minus 0.5 volt to plus 0.6 volt, and logic 1 is represented by 3.9 volt to 5.0 volt. So if you got 3.9 volt to 5.0 volt, it's a logic 1, and if it is minus negative 0.5 volt to plus 0.6 volt, so it's logic 0. Now in addition to the clock, the latch and the transceiver, we have the bus controller, 8288 bus controller. It is used to provide the signal when the microprocessor 8086 operates in a maximum mode, because I told you we have a minimum mode and maximum mode. In minimum mode we have the processor working as a single processor, but in a maximum mode we have a multiprocessor system. So that we will talk in a next lecture. this is enough for this lecture. And here we could see that the pins of the microprocessor, that is S0, S1, S2, they are controlled with the, they are linked with the, connected to the, basically S0, S1, and S2. They are connected to the status output pins of 8086 microprocessor, as you could see here. And it also has the clock input. So this clock input provides internal timing basically, and it must be connected to the clock output. Okay, this clock output, and it has to be connected with the clock input of the bus controller. Okay, it also controls the latch as well as transceiver using the data enable pin or data transfer or receive pin or address latch enable pin. It controls the latch as well as transceiver. So it also controls the bus. It has those outputs which works in the maximum mode of the microprocessor, and we will talk about that in a next vid. Okay, which we have here is like memory read control, memory write control. We can have input output read control, input output write control. Then we can have the interrupt acknowledgement output. Okay, and these all will be discussed in the next vid. Okay, inshallah taala. So hopefully you got the clear idea of how the demultiplexing happens, and multiplexing, how we can use the same address lines for the data as well as address, how that happens. Okay, using the latch and transceiver. Hopefully you got the clear idea, because you have seen, you may have seen the videos on the YouTube, which never talks about the actual thing, which just talks about these pins and this is this, this is this, but it never talks about the actual stuff. Okay, so here I am trying my best to get you the actual stuff. As you could see the here pins now, these pins becomes more, understand, you can understand more about these pins now. Okay, now these are those the maximum mode and minimum mode type pins which will work, which will be the next topic. Okay, we can talk about a little bit about interrupts and non-must interrupts. Okay, maybe we talk these things in the next video. So hopefully you're getting these things, so you got to watch them. You're gonna basically, it looks little elaborate, and but when you once get things in your mind, it becomes very easy to remember these pins, what they do and what they not do. But you have to kind of write the notes and make a memory map so that everything becomes clear. So when you maybe in the beginning it will take some hour or two to concentrate, but later on it will become very easy to draw the pin diagram and to tell which pin does what. Okay, then see you in a next lecture. Until then, ma salama.